All right, good morning, everyone. Today, I'll be covering the key results and takeaways from the SCCE Territory-Wide Buildings Baseline Study. So just a brief outline on today's presentation. First, I'll cover the motivation for us carrying out this Buildings Baseline Study. I'll give a brief overview on the study itself, then move on to some big picture results. And then following that, I'll dive into the individual sections of the report. So starting with the motivation, you may know that SCCE carries out an annual GHG inventory using our energy consumption data and other publicly available transportation data. So we split out these emissions into several categories, the first being residential and non-residential electricity, then residential and non-residential gas, and then on-road and off-road transportation. And you can see these subsectors split out in this bar chart. And having it split out this way is helpful for a high-level understanding of where our emissions are coming from. But in order to tackle building decarbonization, we really need to drill down into that energy consumption data, which is circled in red here. So what that entails is first breaking down this non-residential sector of emissions. So seeing how much of that comes from commercial buildings versus industrial processes versus agriculture, et cetera. Then once we've successfully isolated the building's emissions out of this red circle here, we can then disaggregate those emissions by end use at the building level. And then finally, we can join our energy consumption data with other data sets like tax assessor information to analyze building energy consumption trends with respect to building attributes like vintage, square footage, sector, et cetera. So what is the Buildings Baseline Study? It's essentially a data-driven assessment of energy and emissions in the built environment. The key data sets that we leverage include our electricity and gas historical data, DMV data, tax assessor data, and PG&E interconnection information. The objective of this study is twofold. The first is to develop our understanding of building energy usage and their associated emissions. And the second is to help identify opportunities for targeted decarb policies and programs. And so we first carried out the study in 2019 for the city of Mountain View. And then in 2020, we expanded the scope of the study to cover all of SCCE territory. And that's what I'll be presenting about today. So some big picture figures. This pie chart here shows all energy-related and transportation-related emissions in SCCE territory. You'll see in the orange wedge here that buildings make up about 1/3 of these emissions. And if you break that out further, electricity makes up about 17%, while natural gas makes up about 83% of those buildings' emissions. And we can split this out one step further into their respective customer classes. So in the orange here, you'll see that residential natural gas makes up about half of all buildings emissions in SCCE territory. In the yellow, commercial natural gas makes up about 34%. And the reason for this difference is simply due to a proportionally higher level of natural gas consumption in the residential sector. You'll see in the teal sector here, commercial electricity is responsible for about 15% of buildings emissions compared to only 1.4% for residential electricity. The reason for that discrepancy is twofold. The first is that commercial electricity consumption is about 2.5 times higher than residential consumption. But the more important factor is that there's a higher share of DA, direct access electricity consumption in the commercial sector, which really drives that weighted average emission factor up. So then what we can do with these building level emissions is we can take some end use fractions from the RAS and the SUS surveys and break them out into their respective end uses. So the RAS survey is the residential appliance saturation survey, and the SUS is the commercial end use survey, both from the CEC. And so we used fractions from these surveys and we applied them to our gas and electricity emissions to determine where at the building level these emissions are coming from. And so you can see that gas is responsible for about 5 times more emissions than electricity in the built environment, and that space heating and water heating are the largest emitting end uses, making up about 2/3 of total building emissions. And next, I'm going to dive right into the individual sections of the report, starting with the residential built sector. So this map on the left plots out all of the residential parcels in SCCE territory. So in the blue, we have single-family homes or townhomes. In green, we have MUDs, and in red, we have condos. And those three are the primary property types that we've analyzed in this residential section. This table on the right here just gives you an idea of the distribution of these property types in SCCE territory, as well as the approximate percentage of all electric versus mixed fuel homes. So you can see that single family homes make up the majority of residential units in our territory. And about 5% of those homes are all electric, compared to about 17% of condos and 8% of MUD units. So in addition to residential property type, we also analyze a variety of building attributes, including square footage, vintage, building fuel type, EV versus non-EV homes, and solar versus non-solar homes. And the main metrics that I'll be talking about for these analyses are electricity consumption, gas consumption, and energy use intensity, or EUI. So EUI is measured in units of energy per square foot. And what this does is it allows us to compare between buildings of different sizes and look at the energy consumption trends between them. So starting off with electricity EUI by residential property type and fuel type. So on the x-axis here, we have our month of the year in 2018. And on the y-axis, we have our weighted average electricity EUI for a given property type. So each of the three property types are color-coded. We have the single-family homes in teal, condos in orange, and then MUDs in gray. We've also split it out by building fuel type. So all electric properties are in the dashed lines, and mixed fuel types or mixed fuel homes are in the solid lines. So starting off with mixed fuel homes, we can observe a clear seasonal trend in electricity EUI. We have a peak in the summer due to space cooling needs. And then we also observe a peak in the winter, and this is likely due to seasonal occupancy, in which people tend to stay indoors and spend more of their active hours indoors during colder temperatures. In the all-electric front, we're also seeing a winter peak, but much more significant than in their mixed fuel counterparts. This is likely due to more electric space heating. And another thing to note is that in the winter months, our all-electric properties tend to diverge in terms of EUI. So condos appear to be the least efficient users of electricity, most likely for space heating, followed by single-family homes, and finally followed by MUDs. So next I'll talk about a similar plot, but for gas EUI. So again, we have our months on the x-axis, our gas EUI on the y-axis, and then our property types are color-coded. So you'll see, again, there's a seasonal trend in gas EUI. We have a dip in the summer months and then a peak in the winter months, most likely due to increased gas usage for space heating. You'll also see in the winter months that single-family homes come out as the least efficient users of gas, most likely for space heating purposes, followed by MUDs, followed by condos. And then in the summer months, these EUIs tend to converge, and that points to the relative consistency of gas usage for water heating, as well as for cooking across these three property types. And so after having looked at how EUI might vary by property type and by field type, we also wanted to look at building vintage as an affecting variable. And so in order to isolate building vintage as a factor affecting EUI, we pulled out a subset of residential properties, more specifically single-family homes that were mixed fuel, non-solar, and did not own an EV at that address. And so once we pulled out that subset of homes, we categorized them by their decade built. So between pre-1940 and then by decade all the way through to the 2010s. And then for each cohort, we calculated a weighted average annual electricity EUI in the blue, as well as a weighted average annual gas EUI in the orange. So from this chart, we can see that older single-family homes tend to have the highest both electricity and gas EUIs, and that as a home gets newer, its energy EUI tends to decrease. So this suggests that there's significant potential for both building envelope and appliance efficiency improvements in these older single-family homes, especially homes built before the 1960s. And so that was a brief overview of the residential sector. And so now I'll move on to the commercial sector. So this map on the left plots all commercial and industrial parcels in SVCE territory. So just a quick overview of our commercial analyses. We analyzed 3 primary attributes, first being square footage, second being make sector, and the third being the building's fuel type, so all electric versus mixed fuel. And again, the metrics I'll be speaking to include electricity and gas consumption, as well as electricity and gas EUI. So starting with electricity EUI by NAICS sector. On the y-axis here, we have our NAICS sectors that are present in SVCE territory. And then on the x-axis, we have our annual electricity EUI for that sector. And the way to read this box and whiskers plot is that the ends of the rectangle represent the first and third quartiles of the data. The black line in the middle of the box represents the median value. And then the ends of the whiskers represent the minimum and maximum values. We've also plotted in the turquoise dots the PG&E service area average values, which were taken from the SUSE survey. And we did that really to benchmark our SVCE median values. So a couple of observations, excuse me, a couple of observations here. You'll see that electricity EUI really does vary by NAICS sector, and within each sector there can be a wide range of EUI values, for example, in the public administration sector. But generally, SVCE median values tend to fall at or below the PG&E service area average. So after observing that electricity EUI could vary by sector, we also had the question of how might square footage play into the equation. And so what we did was we took the top electricity consuming sectors in SVCE territory and used them to analyze how sector and square footage both play a part in affecting parcels EUI. And the result of this analysis was that this correlation between electricity EUI and square footage is highly sector dependent. So we really only observed a correlation in 2 sectors, the retail, trade, and accommodation and food services industries. And in these 2 industries, the highest electricity EUIs belonged by far to the smallest parcels that were under 10,000 square feet in size. So this really points to the smallest establishments in these 2 sectors being the least efficient users of energy, of electricity, or the most electricity intensive parcels. We didn't observe this similar correlation in the other sectors that we analyzed up here. And so we carried out a similar analysis for gas EUI. So again, we have our NAICS sectors on the y-axis, and then our gas EUI on the x-axis, and then our PG&E averages plotted in the turquoise dots. So again, we're seeing a wide range of values across sectors and also within each sector. And generally, again, the SPCE median value usually falls at or below the PG&E service area average, with the exception of this warehousing industry. So again, we wanted to explore this question of how sector and square footage impact a parcel's gas EUI. So we took the top gas consuming sectors in SPCE territory for this analysis. And our conclusion was quite similar to the previous. We found that gas EUI to square footage correlation is highly sector dependent. This time we really only observed this correlation in the accommodation and food services sector. And again, the highest EUI in this sector belonged to parcels under 10,000 square feet. And this could really point to restaurants that might be on the smaller side with high gas usage for cooking. And it indicates that gas usage in these particular establishments do not scale linearly with square footage. So this leads to the smallest restaurants being the most gas intensive users. So then what we did was we took our gas and electricity data and we converted them to a common unit to then calculate the commercial parcel's overall energy EUI. So again, we took the top energy consuming sectors in SPCE territory for this analysis. And we found a similar trend in that energy EUI to square footage correlation is highly sector dependent. Again, only observed in the retail trade and accommodation and food services sectors. For these two sectors, energy usage did not scale with square footage, resulting in the highest intensity users belonging to the smallest of establishments. And next, I'm going to touch on some trends that we've observed in our service territory for DER adoption. So first, we leveraged our GMV data to assess the state of EV adoption in SPCE territory. So as of late 2018, SPCE had over 15,000 BEVs in its territory and over 9,000 plug-in hybrids. We were able to link this DMV data with our energy consumption data, and we found that homes with an EV have on average 14% to 20% higher electricity EUI than homes without EVs. And this is likely due to EV charging. And we also plotted EV adoption density by census tract in SPCE territory. In this case, density is characterized by number of EVs per capita in the census tract. And the darkest census tracts are those with the highest rates of adoption, while the gray census tracts are those with the lowest rates of adoption. Next, we carried out a similar analysis for rooftop solar using our interconnection data. We have over 20,000 customers with rooftop solar in our territory, totaling about 190 megawatts of installed capacity. And again, we've plotted adoption density by census tract in this figure here. In this case, density is defined as number of installations per capita. And then lastly, using our interconnection data, again, we performed the same exercise for behind the meter storage. We have approximately 500 customers in our territory with behind the meter battery storage. And you can see the distribution of adoption in this chart here. In this case, adoption density is defined as number of installations per capita. And next, I'll touch a little bit on the equity analysis that we integrated into this study. So we analyzed two primary types of equity metrics in this study. The first one is household level metrics like HARE and FARA. And the second is community level metrics such as Cal and Virus Screen. And these are census tract level metrics as opposed to household level. So starting with Cal and Virus Screen in Figure A, essentially what CES is it's a scoring system that identifies California communities by census tract that are disproportionately burdened by or vulnerable to pollution, as well as other socioeconomic indicators. And so Cal and Virus Screen scores each California census tract according to these environmental and socioeconomic indicators. And then it ranks by percentile how each census tract in California falls in relation to the rest of the state. And then the top 25% highest scoring CES census tracts are then considered disadvantaged communities, or DACs. And so you'll see when compared with the rest of the state, SVCE has about 7 DACs in its territory. And this is useful for a high level understanding of where our most vulnerable populations might be, but it doesn't give us much insight into the other many census tracts in our territory. So what we can do then is take the CES score and regionalize it to SVCE territory only, so that we're not comparing with the rest of the state, but rather only within our region. And so that's what we've done here, and we've bucketed each census tract score into 4 quartiles. The first one being the quote unquote best off in terms of CES, and those are the gray census tracts. And the 4th quartile is the quote unquote worst off census tract in terms of the CES score, and those are in the dark blue. And you can see this gives us some more resolution into where these other census tracts might fall in relation to each other, rather than just taking the statewide DAC designation. So next, I'll jump to Figure D. So this is the Socioeconomic Vulnerability Index, or SEVI. And SEVI is basically an offshoot of CES. It's basically taking only the socioeconomic indicators of the CES score, leaving behind the environmental indicators. So again, we regionalized the SEVI score for SVCE territory only, and then we grouped them into quartiles such that the gray 1st quartile is best off and the dark blue 4th quartile is worst off in terms of SEVI. And what's interesting is that if you compare these regionalized maps between CES and SEVI, we can glean some insights about specific census tracts. So for example, this large one here, you'll see that it ranks as the 3rd quartile, so closer to worst off in terms of CES, but it's actually grouped into the 1st quartile, or best off, in terms of SEVI. So what this tells us is that for this particular census tract, it's more burdened by environmental indicators than it is by socioeconomic indicators. And the last equity metric that I'll touch on is area median income, or AMI. So AMI is pretty straightforward. It essentially takes the median household income of a census tract, and it compares it against the median household income for the entire region. So in this case, again, we've regionalized it to only FCC territory. And we were able to characterize how each census tract fell in relation with the territory-wide median income. And so since this was our first deep dive into an equity analysis, having these metrics to evaluate communities by helped us carry out some initial studies of DER adoption and other household level trends across census tracts. So first, in terms of multifamily housing, we found that nearly half of care customers lived in MUDs versus only 20% of non-care customers. In terms of AMI and SEVI, nearly 40% of customers in the quote-unquote worst off quartiles or census tracts lived in MUDs versus 3 to 8% in the best off census tracts. In terms of home vintage, there is a disproportionate presence of pre-1960 single-family homes and condos in the worst off census tracts in terms of AMI and SEVI. And you might remember that these pre-1960 single-family homes were found to be the least efficient users of both gas and electricity. And then in terms of electrification, we found that only 3 to 4% of single-family homes in the worst off census tracts were electrified, as opposed to 8 to 12% in the best off census tracts. So you might remember we estimated that about 5% of single-family homes in the entire territory were all electric. And lastly, in terms of DER adoption, at a high level, we saw that across all community level metrics, there was a higher per capita density of EV adoption, rooftop solar adoption, and battery storage adoption in the better off census tracts. And so as we receive more and more updated data and we enhance our analyses, we'll be able to track these different trends more closely across our various equity metrics. So I'll just cap it off with some key takeaways. So the first, from all of this discussion, we found that there is a need for building electrification policies and programs as a pathway for deep decarbonization in the built environment. The key end uses to focus on here are natural gas space heating and water heating. So you might remember that natural gas is responsible for about 83% of all built environment emissions in SCCE territory. And that space heating and water heating were by far the largest end uses in that respect. The second takeaway in the residential sector is that single-family homes are an important focus area for deep decarbonization of the built environment, especially those built before 1960. So single-family homes make up the majority of residential units in SCCE territory. And it was also found that single-family homes are the highest intensity gas users when compared to MEDs and condos. And lastly, in the commercial sector, we found that across the board for electricity and gas, as well as energy, EUI correlated more with sector than with square footage. And so this really tells us that when looking at decarbonization policies in the commercial sector, that it's important to take it on a sector-by-sector basis and analyze the trends independently for each industry. And that concludes the webinar. Thank you for attending.